Query in Jakarta persistence. Focusing on query, the Jakarta.persistence.query interface is implemented by each vendor to find persistent objects that meet certain criteria. Jakarta persistence query language, criteria API, and native SQL select queries are executed using the get result list and get single result methods. Update and delete operations, update and delete queries are executed using the execute update method. Here you can see the criteria query encapsulate the clauses of traditional query. Criteria query is a tree of query expression nodes that are used to specify query clauses from where order by in a traditional string-based query language. This figure shows the clauses related to a query. The core expressions are generically type. A few typical expressions are root t, which are equivalent to from clause, predicate, which equates to a Boolean value of true or false in fact it is declared as the interface predicate extend expression Boolean. Path, which denotes the persistent attribute navigated from root question mark root question expression. Root t is a special path t with no parent. Criteria criteria builder is factory for criteria query and query expressions of all sorts. Criteria query is transferred to an executable query which its type information preserved so that the element of selected list can be accessed without any runtime casting. Here the interface abstract query type parameter t in package jakarta.persistent.criteria in module jakarta.persistence. The t is the type of the result, and the abstract query interface defines functionality that is common to both top level queries and subqueries. It is not intended to be used directly in query construction. The interface criteria query the criteria query interface defines functionality that is specific to top level queries. Interface subquery t The subquery interface defines the functionality that is specific to subqueries. A subquery is an expression as its selection item. Interface selection x is the type parameter. X is the here the t the type of the selection item. The selection interface selection. The selection interface defines an item that is to be returned in a query result. Interface predicate. The type of a simple or compound predicate, a conjunction of disjunctions of restrictions. A simple predicate is considered to be a conjunction with a single conjunct. Interface root. Here the type parameter. Here we put x, the entity type referenced by the root. The interface root. The root type in the from the root type in the from clause. Query roots always reference entities. Interface join. Here the type x, the source type of the join, and here the target type of the join. A join to an entity embeddable or basic type. Interface interface expression. T the type of the expression. Type for query expressions. Interface order, an object that defines an ordering of a query results. Here the you can see the abstract query. Here the join is connected to root, and selection, predicate, root, expression, predicate, and predicate are connected to abstract query, and query criteria query and subquery are connected to abstract query here, and the order is connected to criteria query, and query build interacts with criteria query. Here the here 0 or 0 to or 1 selection is connected to abstract query via select, and here predicate 0 to 1 predicates is connected to abstract query via where, and 0 to many root roots are connected to abstract query via from, and 0 to many expression is connected to abstract query via group by, and 0 to 1 predicate is connected to having abstract query via having, and 0 to many order are connected to orders is connected to order abstract criteria query via order by. Here 0 to many join is connected to from. Here you can see generic type arguments T criteria query T select the instance of type X in this graph here. Here you can see criteria API interfaces. The heart of the criteria API is the criteria builder interface obtained from the entity manager interface by calling get criteria builder method. The criteria build interface is a large and serves several purposes within the criteria API. It is a factory with which we create query definition itself, an instance of criteria query interface, as well as many various components of the query definition such as conditional expressions. Criteria build interface provides provides three methods for creating a new select query definition. Depending on the desired result type of the query. The first and most common method is criteria query class type parameter T method, passing in the class corresponding to the result of the query. The second method is a create query without any parameters and correspond to the query with the result type object. The third method is create tuple query. Is used to projection of or report queries where select clause of the query contains more than one expression and you wish to work with the result in a more strongly typed manner. It is really just a convention method that is equivalent to invoking create query tuple.class. Note that the tuple is an instance that contains an assortment of object or data and applies typing to the aggregate part. It can be used whenever multiple items are returned and you want to combine them into a single type object. It is worth noting that despite the name, criteria query instance is not a query object that may be invoked to get results from the database. It is a query definition that may be passed to the create query method and entity manager interface in place of Jakarta persistence QL string. The only real difference between criteria query definition and Jakarta persistent QL string is the method of building the query definition, programming API versus text, and those criteria queries are basically typed, so result type does not have to be specific when invoking create query on entity manager in order to obtain typed query instance. You may also find it useful to think a fully defined criteria query instance as being similar to internal representation of Jakarta persistent QL query that a persistent provider might use after passing the Jakarta persistent QL string. Criteria API is composed of a number of interfaces that work together to model structure of Jakarta persistence query. Criteria builder interface criteria builder used to construct criteria queries, compound selections, expressions, predicates, orderings. Interface tuple element x type parameter x in package Jakarta.persistence in module Jakarta.persistence. The tuple element interface defines an element that is returned in a query result type. Interface selection, here T, in package Jakarta.persistence.criteria in module Jakarta.persistence. Selection interface defines an item that is to be returned in a query result. Interface compound selection. The compound selection interface defines the compound selection item, tuple, array, or result of construction. Here exists the type of the selection item. Interface expression, type for core expressions. Here the type parameter T is the type of the expression. Interface parameter expression T, type of criteria query parameter expressions. Interface parameter T, type for query parameter objects. Interface predicate, the type of a simple or compound predicate, a conjunction or disjunction of restriction. Simple predicate is considered to be a conjunction with a single conjunct. Interface subquery T, the subquery interface defines functionality that is specific to subqueries. A subquery has an expression as its selection item. Here the T is the type of the selection item. Interface criteria query. The criteria query interface defines functionality that is specific to top level queries. T is the type of the defined result. Interface abstract query. The abstract query interface defines functionality that is common to both top level queries and subqueries, that is not intended to be used directly in query construction. T is the type of the result. Interface common abstract criteria. The common abstract criteria interface defines functionality that is common to both top level criteria queries and subqueries, as well as top level criteria queries, subqueries, as well as update and delete criteria operations. It is not intended to be used directly in query construction. Interface criteria update T. The criteria update interface defines functionality for performing bulk update operations using the criteria API. Interface criteria delete T. The criteria delete interface defines functionality for performing bulk delete operations using using the criteria API. Interface path represent a simple or compound attribute path from a bound type or collection. And is a primitive expression. T is the type referenced by the path. Interface fetch represent the joint fetch association for or attribute. Here T is the source type of the fetch and X is the target type of the fetch. Interface fetch parent represent an element of the from clause which may function as the parent of fetches. Interface from the represent a bound type, usually an entity that appears in a from clause but may also be an embeddable belonging to an entity in the from clause. Interface root, the root type in the from clause. Query roots always reference entities. Here the T is the entity type referenced by the root. Interface join, TU here, join to an entity, a join to an entity embeddable or basic type. So here the source type of the joint and here the target type of the joint, the type parameters. Interface plural join. The plural join interface defines functionality that is common to joins to all collection types. It is not intended to be used directly in the query construction. Here the type parameters: source type, collection type, element type of the collection. Interface collection join. Here TU, the collection joint interface is a type of the result of joining to a collection or an association or element collection that has been specified as java.util.collection. Here the source type parameters, the source type of the join and element type of the target collection. Interface set join, type parameter here T, the source type of the join and the element type of the target set. The set join interface is a type of the result of joining to a collection or association or element collection that has been specified as java.util.set. List join, the list join interface is the type of the result set of joining to a collection or an association or element collection that has been specified as java.util.list. Map join, the map join interface is the type of the result of joining to a collection or an association or element collection that has been specified as a java.util.map. Interface order, an object that defines an ordering over the query results. So here you can see criteria builder. Tuple element has sub-interface selection. Selection has sub-interfaces compound selection expressions, and expression has sub-interface parameter expression, and parameter expression has super interface parameter. Selection has a sub-interface compound selection and expression also. See, expression has sub-interfaces predicate, path, subquery, and criteria query here. Criteria query has a super interface abstract query, and abstract query has a super interface command abstract criteria. It has sub interfaces criteria update and criteria delete here. The path has sub interfaces fetch tu and from tu and from tu. Fetch tu has super interface fetch parent tu here, and here you can see order, and from has sub interfaces root and join, and here the root has sub interfaces pura join tuv. Pura join has sub interfaces collection join tu, set join tu, and list join tu, and map join t. Now we are considering query cache. Here you can see query cache. The Jakarta persistent doesn't currently define a mechanism for caching of queries. Data nucleus provide 3 levels of caching. Here, query caching with the data nucleus. Data nucleus provide 3 levels of caching. Generic compilation. When a query is compiled, it is initially compiled generically into expression trees. This generic compilation is independent of the data store in use, so it can be used for other data sources. This can be cached. Data store compilation. After query is compiled into expression trees above here, it is then converted into a native language of the data store in use. For example, RDBMS is converted to SQL. This can be cached. Results when the queries run and return object of the candidate type, you can cache the identities of the result objects. Here you can see the query, user query, JDOQL, JPQL, the select from my class where if ID 1, if FLD1 equal colon param. User query is connected to generic compilation, expression trees for each query component, data store independent. Generic compilation is connected to data store compilation, data store native query, for example SQL, etc. Select asterisk from my TBL where FLD COL equal question mark. An example we can consider interface query. Interface used to control query execution. This is in module Jakarta.persistence and package Jakarta.persistence. As an example too, we can consider this code segment here with entity manager. You can see here the create query method, and here the Jakarta persistent query string. The create query method here creates an instance of query for executing a Jakarta persistent query language statement. Here you can see the set parameter method in query, bind an argument value to a named parameter. Here bind an argument value to a name parameter here. This is the parameter name and this is the parameter value. Here you can see a set max result method in query interface. Set the maximum number of results to retrieve, here 10. Here you can see a get result list in query interface. Execute a select query and return the query results as an untyped list. For type query instances, the query result type is determined in the case of criteria queries by the type of query specified when the criteria query is created. And in the case of Jakarta persistence query language queries, the type of the result is determined by the result class argument to the create query or create named query method, and select list of query must contain only a single item which must be assignable to the specified type. Here you can see type query interface used to control the execution of typed queries. Here you can see entity managers, the create query method in entity manager here with the parameter. This is the criteria query parameter, a criteria query object here, and this create query method creates an instance of typed query for executing a criteria query. Here you can see a get single result method of type query. Execute a select query that returns a single result. And the type query is in module jakarta.persistence and package jakarta.persistence. As an example 4, we can consider this one. This example illustrates the case where a native SQL query is created dynamically using the create native query method, and the entity class that specify the type of the result is passed as an argument. When executed, this query will return a collection of all order entities for items name widget. Here we can see the method create native query in entity manager. Create an instance of query for executing a native SQL query. Here you can see a native SQL query string, and this is the class of the resulting instances. As an example 5, we can consider this. Here you can see the method create stored procedure query method in entity manager. Here create an instance of stored procedure query for executing stored procedure in the database. Here you can see the procedure name, and the interface stored procedure query interface used to control procedure query execution, control stored procedure query execution. And design Jakarta dot persistent module and Jakarta dot persistent package. As an now we are considering query interface in query APIs. Interface query in package Jakarta.persistent in module Jakarta.persistence. Interface used to control query execution. Typed query interface type query type parameter X in package Jakarta.persistence in module Jakarta.persistence. Interface used to control the execution of typed queries. Tuple interface tuple in package Jakarta.persistence in module Jakarta.persistence. Interface for extracting the elements of a query result tuple. Tuple element interface tuple element X in package Jakarta.persistence in module Jakarta.persistence. The tuple element interface defines an element that is returned in query result tuple. Parameter interface parameter type parameter T. The package Jakarta.persistence in module Jakarta.persistence type for query parameter objects. Stored procedure query interface stored procedure query in package Jakarta.persistence in module Jakarta.persistence. Interface used to control stored procedure query execution. Here you can see query execution. You can see the example. The interface query in package Jakarta.persistence in module Jakarta.persistence. You can see the method get result set, the list get result set. Execute the select query and return the query result as an untyped list. With query execution, the Jakarta persistent query language criteria API native select queries are executed using get result list and get single result method. Update and delete operations, update on delete queries are executed using execute update method. For typed query instances, the query result type is determined in the case of criteria queries by the type of the type of the query specified when the criteria query object is created. In the case of Jakarta persistent query language queries, the type of the result is determined by the result class argument in the create query or create named query method, and select the list of the query must contain only single item which must be assignable to a specific type. The query instances, the element of the query result whose select list consists of more than one select expressions of the type object array. If the select list consists of only one select expression, the elements of the query result of the type object. When the native SQL queries are used, the SQL result set mapping determine how many items, entities, scalar values, etc. are returned. If multiple items are returned, the elements of the query result are of type object array. If a single item is returned as the result of the SQL, the result set mapping or the result set class is specified, the element of the query result are of the object type. Stored procedures queries can be executed using get result set. Get a single result and execute methods. Stored procedures that perform only updates or deletes can be executed using execute update method. An illegal argument exception is thrown if the parameter instance is specified and that does not correspond to the parameter of the query. If parameter name is specified that does not match the corresponding that does not correspond to the parameter that does not correspond to the named parameter of the query of the positional. If the positional value is specified that does not correspond to the positional parameter of the query, or if the type of the parameter is not valid for the query, this exception may be thrown when the parameter is bound or the execution of the query may fail. The effect of applying set max result or set first result to a query involving fetch join server collections is undefined. The use of set max result and set first result is not supported for stored procedure queries. Query and type query methods other than execute update method are not required to be invoked within the transaction context unless the lock mode other than lock mode type none has been specified for the query. In particular, the get result set and get single result methods are not required to be invoked within the transaction context unless such a lock mode has been specified for the query. If an entity manager with the transaction scope persistent context is in use, the resulting entities will be detached. If the entity manager with the extended persistent context is used, they will be managed. Whether the stored procedure query should be invoked in a transaction context should be determined by the transactional semantics or requirement of the stored procedure implementation and the database in use. In particular, problems may occur if the stored procedure initiates a transaction and transaction is already in effect. The state of the entities returned by the stored procedure query invocation is determined as runtime exception other than no result exception, non-unique result exception, query time out exception, and lock timeout exception thrown by the method of the query. Type query and stored procedure interfaces other than those methods described below cause the current transaction to be marked for rollback if the persistent context is joined to the transaction. On the database platform on which the query timeout causes transaction rollback, the persistent provider must throw the persistent exception instead of query timeout exception. Runtime exceptions are thrown by the following methods of the query: type query and stored procedure query interfaces do not cause current transaction to be marked for rollback. Get parameter, set parameter, get parameter, get parameter, get parameters, get parameter values, get output parameter value, and set get lock mode. The runtime exception thrown by the method of the tuple and tuple element and parameter interfaces do not cause the current transaction to be marked for rollback. Now we are considering queries and flush mode. If the persistence context has been joined to the current transaction, the persistent provider must not flush the database regardless of the flush mode setting. Enum flush mode type in package Jakarta.persistence in module Jakarta.persistence flush mode setting. The flush mode setting affects the result of the query as follows. When the queries are executed within transaction, if the flush mode type auto .auto is set on the query, the type query or stored procedure query object, or if the flush mode settings for the persistent context is auto, the default, and the flush mode get mode setting has not been specified for the query object, the persistent provider is responsible for ensuring that all updates to the state of all entities in the persistent context which could potentially affect the result of the query are visible or to the processing of the query. The persistent provider implementation may achieve this by flushing those entities to the database or by other means. If the flush mode type.commit is set, the effect of updates made to the entities in the persistent context upon queries are unspecified. If the persistence context has not been joined to the current transaction, the persistent provider must not flush the database regardless of the flush mode setting. If there is no transaction active, the persistent provider must not flush to the database. The flushing occur at the transaction commit. The provider may flush at other times but is not required to. The default flushing to occur at query execution. Now we are considering queries and lock mode. The set lock mode method of the query or type query interface or the lock mode element of the named query annotation may be used to lock the result of the query. The query set lock mode type lock mode in interface query in package Jakarta.persistence in module Jakarta.persistence. Set the lock mode type to be used for query execution. The set lock mode method for query or type query interface or the lock mode element of the named query annotation may be used to lock the result of a query. A lock is obtained for each entity specified in the query result, including entities passed to the constructors in the query select was. If the lock mode type is pessimistic read, pessimistic write, pessimistic force increment, and the query returns scalar data, for example, the values of the entity field or properties including scalar data passed to the constructors in the query select cause, the underlying database rows will be locked, but the version columns of any entities corresponding to the scalar data will not be updated unless the entities themselves are also otherwise retrieved and updated. If the lock mode is optimistic or optimistic force increment, and the query returns scalar data, any entities returned by the query will be locked, but not locking. The locking will occur for the scalar data that does not correspond to the state of the entity instance in the query result. If the lock mode other than none is specified for the query must be executed within the transaction, and the persistent context must be joined to the transaction, or the transaction required exception will be thrown. Locking is supported by Jakarta persistence query language queries and criteria queries only. If the set lock mode and get lock mode method is invoked on a query that is not a Jakarta persistent query language, select query or criteria query, the illegal state exception may be thrown or the query execution will fail. Now we are considering query hints. The following hint is defined by this here by for use in query configuration. This hint may be used with the query type query or stored procedure query, set hint method, or named query, named native query, or named stored procedure query annotations. It may also be passed as a property to the persistent.create entity manager factory method and used in the properties element in the persistence.xml. When used in the create entity manager factory method, the persistent.xml and file and the annotations The timeout hint serves as a default value which can be selectively overwritten by the set hint method. Portable applications should not rely on this hint. Depending on the persistent provider and database in use, the hint may or may not be observed. Vendors are pointed to support the use of traditional vendor specific hints. Specific hints must not be used. The Jakarta.persistence namespace. Vendor specific hint must be ignored if they are not understood. Now we are considering parameter objects. Parameter objects can be used for criteria queries and Jakarta persistence query, Jakarta persistence query language queries. Interface parameter type parameter T in package Jakarta.persistence in module Jakarta.persistence. Type for query parameter objects. Parameter objects can be used for criteria queries and for Jakarta persistence query language queries. Implementation may support the use of parameter object for native queries. However, support for parameter object for the native queries is not required by the specification. The use of the parameter object for native queries will not be portable. Mixing of parameter object with the named and positional parameters is invalid. A portable application should not attempt to reuse the parameter object obtained from a query or type query instance in the context of a different query or type query instance. Now we are considering named parameter. Named parameter of Jakarta persistence query language query is an identifier that is prefixed by the colon symbol. Named parameters can be used for Jakarta persistence query language queries, for criteria queries, although use of parameter objects to be preferred, and for stored procedure queries that support named parameters. Named parameters are case sensitive. Mixing of named and positional parameters is invalid. Named parameter for Jakarta persistent query language query is an identifier that is prefixed by the name colon symbol. The parameter names passed to the set parameter methods of the query and type query interfaces do not include this colon prefix. Now we are considering positional parameters. When binding the queries of the positional parameters, the numbering start as 1. Only positional parameter binding and positional access to result items may be portably used for native queries, except for stored procedure queries for which the names parameters have been defined. When binding the values of positional parameters, the numbering starts with as 1, and it is assumed that for native queries the parameter themselves use the SQL syntax, for example question mark rather than question mark 1. The use of positional parameters is not supported for criteria queries. Now we are considering named queries. Following is an example of the definition of a named query defined in metadata. The annotation typed named query in package Jakarta.persistence in module Jakarta.persistence specified a static named query in the Jakarta persistence query language. Query names are scoped to the persistent unit. The named query annotation can be applied to an entity or mapped superclass. Named queries are static queries expressed in metadata or query registers by means of the entity manager factory. Add named query method. This is entity manager, so in the entity manager factory, add named query method. Named queries can be defined in the Jakarta persistence query language or in SQL. Query names are scoped to the persistent unit. The following is an example of definition of a named query defined in metadata. The following is an example of the use of a name query. Now we are considering polymorphic queries. For example, the following query returns the average salary of all employees, including subtypes of employee, such as manager and exempt. By default, all queries are polymorphic. That is the from clause of a query designate not only instances of the specific entity classes to which the explicitly refers, but subclasses as well. The instances returned by the query include instances of subclasses that satisfy the query conditions. For example, the following query returns the average salary of all employees, including subtypes of employee such as manager and exempt. So here the employee has subtypes of subtypes such as manager and exempt. Now we are considering returning manage entities from native queries. The following example illustrates the case where the native SQL query is created dynamically using a create native query method, and entity class that specifies the type of the result is passed as an argument. The method query create native query string SQL string and class result class create an instance of a query for executing native SQL query. The persistent provider is responsible for performing mapping between the values returned by the SQL query and the entity attributes in the accordance with the object relational mapping metadata for the entity or entities. In particular, names of the columns of the SQL result are used to map to the entity attributes as defined by its metadata. This mapping includes the mapping of the attributes of any embeddable classes that are part of the non-collection values entity state, and attributes correspond to the foreign keys contained as part of the entity state. When an entity is to be returned from a native query, the SQL element should select all the columns that are mapped to the entity object. This should include foreign key columns to related entities. The result obtained when insufficient data is available are undefined. In the simplest case, that is when the result of a query are limited to entities in a single entity class, the mapping information can be derived from the columns of the SQL result and the object relational mapping metadata. It is sufficient to specify only the expected class of the entity result. The following example illustrates the case where the native SQL query is created dynamically using create native query method, and the entity class that is specified the result of the type of the result is passed as an argument. When executed, this query will return a collection of order entities for item named widget. The SQL result set mapping metadata annotation, which is designed to handle more complex cases, can be used as an alternative here. For a query shown the query shown here, the SQL result set mapping metadata for the query result type might be specified as follows here. The same result is produced by the native query here then can then obtained by the following. When multiple entities are returned by the SQL query, or when the column names of the SQL query result do not correspond to those of the object relational mapping metadata, the SQL result set mapping metadata definition must be provided to specify entity mapping. Now we are considering named stored procedure queries in stored procedures. Unlike in the case of named query, native query, the named stored procedure query annotation names the stored procedure that exists in the database rather than providing a stored procedure definition. Annotation type named stored procedure query in package Jakarta.persistence in module Jakarta.persistence specified the names of the stored procedure, its parameters, and its result type. Unlike in the case of named native query, the named stored procedure query annotation names the stored procedure that exists in the database rather than providing stored procedure definition. The named stored procedure query annotation specifies the types of all parameters to the stored procedure, their corresponding parameter modes, in out, ref cursor, and how result set, if any, are to be mapped. The name that is assigned to the stored procedure in the named stored procedure query annotation is passed as an argument to the native create named stored procedure query method to create an executable stored procedure query object. The stored procedure may return more than one result set. As with the native queries, the mapping of the result set can be specified either in terms of result classes or as a result set mapping annotation element. If there are multiple result sets, it is assumed that they will be mapped using same mechanism. For example, all via a set of results class mapping or all via a set of result set mapping. The order of specification of these mappings must be the same as the order in which result set will be returned by the stored procedure invocation. If the stored procedure returns one or more result set and no result classes or result set mapping element has been specified, the result set will be returned as a list of type object array. The combining of different strategies for the mapping of the stored procedure result set is undefined. Stored procedure parameter metadata needs to be provided for all parameters. Parameters must be specified in the order in which they occur in the parameter list in the stored procedure. If the parameter names are used, the parameter names is used to bind the parameter value and extract the output value if the parameter is in-out or out parameters. If the parameter names are not specified, it is assumed that the positional parameters are used. Mixing of named and positional parameters is invalid. Now we are considering an overview in query language. The Jakarta persistent query language is a query specification language for string-based dynamic queries and static queries expressed through metadata. It is used to define queries over persistent entities defined by designed by the specification and their persistent state and relationships. Jakarta persistent query language can be compiled to a target language such as SQL of a database or other persistent store. This allows the execution of queries to be shifted to a native language facilities provided by the database instead of requiring queries to be executed on runtime representation of the entity state. As a result, query method can be optimizable as well as portable. The query language uses the abstract persistent schema of entities, including their embedded object and relationships, for its data model and it defines operators and expressions based on this data model. It uses a SQL-like syntax to select object or values based on the abstract schema types and relationships. It is possible to pass and validate queries before entities are displayed. The term abstract persistent schema refers to the persistent schema abstraction, persistent entities, their state, and their relationships over which Jakarta persistent queries operate. Queries over this persistent schema abstraction are translated into queries that are executed over the database schema to which entities are mapped. Queries may be defined in metadata annotation, so SQL descriptor. The abstract schema types of a set of entities can be used in query if the entities are defined in the same persistent unit as the query. Path expressions path expressions allow for navigation or relationships defined in the persistent unit. A persistent unit defines the set of classes that are related or grouped by the application to which must be co-located in their mapping to a single database. Now we are considering select statements in statement types. In BNF syntax, a select statement is defined as here. A select statement is a string which consists of following clauses. Select clause which determines the type of the object or values to be selected. From clause clause which provides a declaration to designate the domain to which the expression specified in the other clauses of the query apply. The optimal where clause which may be used to restrict the result that were returned by the query. Optional group by clause which allows the query results to be aggregated in terms of groups. Optional having clause which allows filtering of aggregated groups. Optional order by clause which may be used to order the results that are returned by the query. In BNF syntax, select statement is defined as here. The select statement must always have select and from clause. The square brackets indicates that the other clauses are optional. Now we are considering abstract schema types and query domains. An example here. This example assumes that the application developer provides several entity classes representing orders, products, and line items. And an embeddable address class representing shipping address and billing addresses. The abstract schema types for the entities are order, product, and line item respectively. There is one-to-many relationship between order and line item, and entity line item is related to product in many-to-one relationship. The classes are logically in the same persistent unit as shown in here. Query to select orders can be defined by navigating over the associated fields, and the state fields are defined by order and line item. A query to find all orders with pending line items might be written as follows here. Here the abstract persistent schema for several entities with defined in the same persistent unit. This query navigate over the association field line items of the abstract schema, type order to find the line items, and uses the field shipped of line item to select those orders that have at least one line item that has not yet been shipped. Note that this query does not select orders that have no line items. Although reserved identifiers such as distinct, from, as, join, where, and false appear in uppercase, in this example the reserved identifiers are case insensitive. Select clause of this example designate the return type of this query to be a type of order. Because the same persistent unit defines the abstract persistent schema of the related entities, the developer can also specify the query over orders utilizes the abstract schema type of products, and hence the state fields and associated fields of both abstract schema types of order and product. For example, if the abstract schema type product has a state field named product type, a query over orders can be specified using the state fields. Such a query might be able to find all orders of products with the product type office supplies. The query for this might be as follows. Because order is related to product, by means of relationship between order and line item, and between line item and product, navigation using associated field line items, and product navigation using associated fields line items and products is used to express the query. This query is specified by using the entity name order, which designate the abstract schema type over which the query ranges. The basis for the navigation is provided by the associated field line items and product of the abstract schema type order and line item respectively. Now we are considering from clause and navigational declarations, identification variables in from clause and navigational declarations. For example, consider the previous query. An identification variable is a valid identifier declared in the from clause of a query. All identification variables must be declared in the from clause. Identification variables cannot be declared in other clauses. An identification variable must not be reserved identifier or have the same name as any entity in the same persistent unit. Identification variables are case sensitive. An identification variable evaluates to a value of a type of the expression used in the declaration variable. For example, consider the previous query here. In the from clause declaration line items L, the identification variable L evaluates to any line item value directly reachable from the order. The associated field line items in a collection of instances of abstract schema type line item, and the identification field L refers to an element of this collection. The type of the L is the abstract schema type line item. The identification variable can range over any entity, embeddable or basic abstraction schema type. An identification variable designate an instance of an abstract schema type or an element of a collection of abstract schema types, abstract schema type instances. Note that for identification variable referring to an instance of an association or collection represented by java.util.map, the identification variable is of the abstract schema type of the map value. An identification variable always designate the reference to a single value. It is declared in one of three ways: a range of variable declaration in the join clause, or in a collection member declaration. Range of variables. In a range variable, in a join clause, or in a collection member declaration. And identification variable declarations are evaluated from left to right in the from clause. And the identification variable declaration can use the result of the preceding identification variable declaration of the query string. All identification variables used in select, where, order by, group by, having clause of the select or delete statement must be declared in the from clause. The identification variable used in where clause of an update statement must be declared in the update clause. Identification variables are extremely qualified in these clauses. Essential identification variables are essentially quantified in this clause in clause variables in these clauses. This means an identification variable represents a member of a collection or instance of an entity abstract schema type. An identification variable never designate a collection in its entirely. An identification variable is scoped to a query or subquery in which it is identified and is visible to any subqueries within that query scope that do not define the identification variable of the same name. Now we are considering where clause. A where clause is defined as follows. A where clause is a query consists of a conditional expression used to select object or values that satisfy the expression. The where clause restricts the result of the select statement or scope of an update or delete operation. A where clause is defined as follows. The group by construct enabled aggregation of values according to the properties of an entity class. Having construct enable the condition to be specified that further restrict the query result as a restriction upon groups. Syntax of the having clause is as follows. The group by and having construct this is the syntax as follows here. Here we are considering the literals in conditional expressions. For example, here a literal string literal is enclosed in a single quotes. For example, string literal that includes a single quote is represented by two single quotes. That includes a single quote is represented by two single quotes. For example, literal quotes, literal quote s quote. Single literals are in queries like string literals and use Unicode character encoding. The use of Java escape notation is not supported in the query literals. String literals. Extract numerical literals support the use of Java integer literal syntax as well as SQL extract numeric literal syntax. Appropriate suffixes can be used to indicate the specific type of numeric literal in accordance with the Java language specification. Support for the use of hexadecimal and octal numeric literals is not required by the specification. Enum literals support the use of Java enum literal syntax. Fully qualified enum class name must be specified. The JDBC escape syntax may be used for specification of date, time and timestamp literals, for example. The portability of this syntax for date, time, and timestamp literal is dependent upon the JDBC driver in use. Persistent providers are not required to translate this from this syntax into native syntax of the database or driver. Boolean literals are true and false. Entity type literals are specified by the entity names, for example, customer. Although resolved literals appeared in uppercase, they are case insensitive. Now we are considering group by and having examples are here. Some examples are here. The group by construct enables the aggregation of results values according to a set of properties. The having clause having construct enable condition to be specified further restrict the query result. In such conditions are restrictions upon the groups. The syntax of the group by and having clauses is as follows. If the query contains both where clause and group by clause, the effect is that of the first applying the where clause, then forming the group and filtering them according to having clause. Having clause causes the groups to be retained and retained that satisfy the condition of having clause. Requirement of for the select clause when group by is used follow those of SQL, namely any item that appears in the select clause other than as an aggregate function or as an argument to an aggregate function must also appear in the group by clause. In forming groups, null values are treated as the same as grouping purposes. As the same for grouping purposes. Grouping by an entity is permitted. In this case, the entity must contain no serialized state field or lob values state field that are eagerly fetched. Grouping by an entity that contains serialized state fields or lob values state fields is not portable, since the implementation is permitted to eagerly fetch fields or properties that have been specified as lazy. Grouping by an embeddables is not supported. Having clause is used to filter over groups and contain aggregate functions or attributes including the groups and or functions or other query language operations or attributes that are used for grouping. It is not required that an aggregate function used in having clause also be in the select select clause. If there is no group by clause and the having clause is used, the result is treated as a single group, and the select list can only consist of aggregate functions. The use of having clause in the absence of group by is not required to be supported by an implementation of this in this Java persistent specification. Jakarta persistent specification. Portable application should only rely on having without use of group by. Portable application should not rely on having without use of group by. The examples are here. Some examples you can see here. Now we are considering select clause. For example, here, and select clause denotes the query result. More than one may be returned from the select clause as a query. Select clause can contain one or more of the following elements: identification variables, that ranges of abstract schema type, single values path expressions, and scalar expression, and aggregate expression, a constructor expression. Select clause has following syntax here. For example, here in the following example, the video inventory is a map from the entity movie to the number of copies in the stock. And note that select clause must be specified to return only a single value expressions. The query below the query is therefore the query below this one is not valid. The distinct keyword is used to specify that the duplicate values must be eliminated from the query result. The distinct is if the distinct is not specified, duplicate values are not eliminated. The result of the distinct or embeddable object or map entity result is undefined. Standard identification variables in the select clause may optionally be qualified by the object operator. The select clause must not use the object operator to qualify path expressions. The result variable may be used to name the select item in the query result. Example here. This is not valid. Now we are considering order by clause. For example, the 4 queries below here are legal. The order by clause allows the object or values that are returned by the query to be ordered. The syntax of the order by clause is here. An order by item must be one of the following. A field path expression that evaluate to an ordinary state field of an entity or embeddable class abstract schema type designated in the select clause by one of the following: a general identification variable, a single valued object path expression. A state field path expression that evaluate to the same state field of the same entity or embeddable abstract schema type as an state field path expression in the select clause. A general identification variable that evaluates to a same map field of the same entity or embeddable abstract schema type as the general identification variable in the select clause. A result variable that refers to an orderable item in the select clause for which the same result variable has been specified. This may be the result of the aggregate expression, scalar expression, or state field path expression in the select clause. For example, 4 queries here are legal. The following queries are not here. These are not legal because the order by item is not reflected in the clause of the query. If the more than one order by item is specified, the left to right sequence of the order by elements determines the precedence, whereby the leftmost order by item has the highest precedence. The keyword ASC specify the ascending order to be used for the associated order by item. The keyword DESC specify the descending order to be used. Ascending ordering is the default. SQL rules for ordering of null values apply. That is, all null values must appear before all non-null values in the ordering, or all null values must appear after all null values in the ordering, but it is not specified which. The ordering of the query result is perceived in the result of the query execution method. Order by clause is used. So these two queries are not these two are not legal. Now we are considering bulk update and delete operations. These are the examples. Uh, Bulk update and delete operations apply to entities of a single entity class together with its subclasses, if any. Only one entity abstract schema type may be specified in the from or update clause. Syntax of these operations is as follows here. Syntax of the where clause, you can see here. The delete operation only applies to entities of specified class and its subclasses. It does not cascade to related entities. The new value specified for an update operation must be compatible in the type with the field to which it is assigned. Bulk update maps directly to database or update operation, bypassing optimistic locking checks. Portable applications must manually update the value of the version column if desired, and or manually validate the value of the version column. The persistence context is not synchronized with the result of a bulk update or delete. Caution should be used when executing bulk update or delete operations, because they may result in inconsistencies between the database and entities in the active persistent context. In general, bulk update and delete operations should only be performed within a transaction in a new persistent context or before fetching and accessing entities. Those states might be affected by such operations. Examples are here. Now we are considering null values. When the target of the reference does not exist in the database, its value is regarded as null. The SQL null semantics define the evaluation of conditional expressions containing null values. The following is a brief description of these semantics. Comparison of arithmetic operation with null value always yield an unknown value. Two null values are not considered to be equal. Comparison yields an unknown value. Comparison of arithmetic operation with unknown values always yield an unknown value. The is null or is not null operators convert null state field or single valued value object value into respectful true or false value. Boolean operators use three valued logic defined in these three tables. The Jakarta persistent query language defined the empty string quotation as a string with zero length, which is not equal to a null value. However, null values and empty strings may not always be distinguished when the queries are mapped to some databases. Application developers should therefore not rely on the semantics of the query comparison involving empty string and null value. Here, true and true, true and false, false, and true and unknown is unknown. Likewise, as you can see here, it's a false and unknown is false here, unknown and unknown is unknown, true and unknown is true, false and unknown is unknown, and unknown, true or unknown is true, false and or unknown is unknown, and unknown or unknown is unknown. Not true, false, not false, true is, and not unknown, unknown. Now we are considering equality and comparison semantics. Only the values of like types are permitted to be compared. Only a type is like another type if they correspond to a same Java language type, or if one is a primitive Java language type and other is wrapped Java class type equivalent. For example, int and integer are like types in the sense. There is one exception to this rule. It is valid to compare numeric values for which the rules of numeric promotions apply. Conditional expressions attempting to compare unlike types values are disallowed except for the numeric case. Note that the arithmetic operations and comparison operations are permitted to be applied to state field and input parameters of the wrapped Java class equivalents to the primitive numeric data types. Two entities of the same abstract schema are equal if and only if they have same primary key values. Not equality or inequality comparisons or enums are required to be supported. Comparisons of instances of embeddable class or map entry types are not supported. Here you can see we are considering some examples, simple queries in examples. Here find all orders. Here find all orders that need to be shipped to California. Find all find all states which there are orders. Now we are considering BNF notation summary in BNF. Here the summary grouping, optional construct, 0 or more, 1 or more, and alternates. Now we are considering an overview in criteria API. Jakarta.persistent.criteria, the package Jakarta.persistent.criteria in module Jakarta.persistent, the Jakarta persistent criteria API. The Jakarta persistent criteria API, like the Jakarta persistent query language, is based on the abstract persistent schema of entities, the embedded objects, and their relationships as its model data model. This abstract persistent schema is materialized in the form of metamodel object over which the criteria API operates. The semantics of the criteria queries are designed to reflect those of Jakarta persistent query language queries. The syntax of the criteria API is designed to allow the construction of an object-based query graph whose nodes correspond to the semantics query elements. Java language variables can be used to reference individual nodes in the criteria query object as it is constructed or modified. Such variables, when used to refer to the entities and embedded types that constitute the query domain play a role analogous that of the identification variables Jakarta persistent query language. These concepts are further described later. The metamodel on which criteria core is based is presented in the documentation. The static metamodel classes that can be used in the constructing strongly typed criteria queries are also described in the documentation. Now we are considering static metamodel classes in metamodel. This is an example. Assume the order entity below here. The annotation is static metamodel in package jakarta.persistent.metamodel in module jakarta.persistence. The static metamodel annotation specified that the class is a metamodel class that represent an entity mapped superclass or embeddable class designated by the value element. Assume mode entity below here. And the corresponding canonical metamodel class order is as follows. Now we are considering here criteria builder interface in criteria API interfaces. Interface criteria builder in package jakarta.persistent.criteria in module jakarta.persistence used to construct criteria queries, compound selections, expressions, predicate, orderings. Now we are considering criteria query API usage. The jakarta.persistent.criteria API interfaces are designed to both allow criteria queries to be constructed in a strongly typed manner using metamodel objects to provide type safety and to allow for string based use as an alternative. Persistent package jakarta.persistent.criteria in module jakarta.persistence, Jakarta persistent criteria API. Yeah. The metamodel objects are used to specify navigation through joins and through path expressions. Type-safe navigation is achieved by specification of the source and target types of the navigation. Strings may be used as an alternative to metamodel object. Thereby, joins and navigations are specified by the use of strings and that correspond to attribute names. Using either the approach based on metadata model or string based approach, queries can be constructed both statically and dynamically. Both approaches are equivalent to in terms of the range of queries that can be expressed in operational statements. Now we are considering criteria query routes in query routes in constructing criteria queries. When executed, this query cause all instances of the customer entity to be returned. The module interface criteria query in package jakarta.persistent.criteria in module jakarta.persistence. The criteria query interface defines the functionality that is specified to top level queries. Interface root type x type parameter x in package jakarta.persistent.criteria in module jakarta.persistence. A root type in the from clause. Query roots always reference entities. A criteria query is constructed through the creation and modification of a Jakarta.persistent.criteria.criteria query object. The criteria builder interface is used to construct criteria query, criteria update, criteria delete object. Criteria build implementation is accessed through the get criteria builder method of the entity manager or entity manager factory interface. For example, here the criteria root object is criteria query object is object defines a query over one or more entity embeddable or basic abstract schema types. The root object of the query are entities from which the other types are reached by the navigation. A query root plays a role analog to that of the range variable in the Jakarta persistent query language and forms the basis for defining the domain of the query. A query root is created and added to the query by use of the from method of the abstract query interface from which the both criteria query and subquery interface inherit. The arrangement to from method is the entity class or entity type instance for the entity. The result of the from method is a root object. The root interface extends from interface which represent object that may occur in the from clause of the query. The criteria object may have more than one root. The addition of a query root that has the semantic effect of creating a Cartesian products between the entity type referenced by the added root and those of the other roots. The following core illustrates the definition of a query root. When executed, this query causes all instances of customer entity be returned. Now we are considering constructing strongly typed queries using Jakarta persistent meta model interfaces. For example, here interface Jakarta interface meta model provide an meta model in package Jakarta persistent meta model in module Jakarta persistence provide access to the meta model of a persistent entities in a persistent unit. Strongly typed queries can also be constructed either statically or dynamically in the absence of generated meta model classes. The Jakarta persistent meta model interfaces are used to access the meta model object that correspond to the managed classes. The following examples illustrate this approach. This meta model interface is obtained from the entity manager or entity manager factory for the persistent unit and then used to obtain corresponding meta model object for the managed types referenced by the queries. Now we are considering the use of criteria API with strings to reference attributes. This example. The criteria API provides an option to specifying attribute references using joins and navigation by attribute names as argument to various join, fetch, and get methods. The resulting queries have the same semantics but do not provide same level of type safety. Example in this section illustrate this approach. This example this query is equivalent to the following Jakarta persistent query language query. It is not required that type parameters be used. However, their omission may result compiler warnings as with the below version of the same query. Now we are considering query modification. The criteria query object might then be modified to reflect different predicate conditions. For example, here the interface criteria query the criteria query type parameter t where predicate restrictions modify the query to restrict the result according to the conjunction of the specified restriction predicates, replaces the previously added restrictions if any. If no restrictions are specified, any previously added restrictions are simply removed. This method only overrides the return type of the corresponding abstract query method. The a criteria query criteria update or criteria delete object may be modified either before or after query or type query object has been created, executed from it. For example, such modification may enter replacement of the where predicate or the select list. Modification may result in the same query object based being refused for several query instances. For example, the user might create and execute a query from the following criteria query object. Criteria query object might then be modified to reflect the different predicate condition. Note, however, that query element in this example predicate conditions are dependent on the criteria query, criteria update, or criteria delete instance, and are thus not portably reusable with different instances. Now we are considering query execution. A criteria query is executed by passing the criteria query, criteria update, or criteria delete object to the criteria create query method of the entity manager interface to create an executable type query object, or in the case of criteria update and criteria delete, the query object, which can then be passed to one of the query execution methods of the type query or query interface. Interface type query type X in package Jakarta.persistence in module Jakarta.persistence interface used to control the execution of type queries. A criteria query is executed by passing a criteria query, criteria update, or criteria delete object to the criteria create query method of the entity manager interface to create an executable type query object, or in the case of criteria update or criteria delete, a query object, which can then be passed to one of the execution method of the type query or query interface. A criteria query, criteria update, or criteria delete object may be further modified after executable query object has been created from it. The modification of the criteria query, criteria update, or criteria delete object does not have any impact on the already created executable query objects. If the modified criteria query, criteria update, or criteria delete object is passed to the criteria query method, passed to the create query method, the persistent provider must ensure that the new executable query object is created and returned that reflect the semantics of the change query definition. Criteria query, criteria update, criteria delete object must be serializable. The persistent vendor is required to support the subsequent deserialization of such an object into a separate JVM instance of that vendor's runtime, where both runtimes instances have access to any required vendor implementation class. Criteria query, criteria update, criteria delete objects are not required to be interoperable across vendors. Now we are considering entity fetch graph semantics in use of entity graphs to find and query operations in entity graphs in entity operations. When Jakarta persistence, this is an example. When Jakarta.persistent.fetch graph property is used to specify entity graph, attributes are specified by the attribute nodes of the entity graphs are treated fetch type.eager, and attributes are not specified as treated fetch type.lazy. The following rules apply depending on attribute types. The rules of these sections are applied recursively. Primary key or version attribute never needs to be specified in an attribute node of the fetch graph. This applies to the composed primary keys as well, including embedded ID primary keys. When an entity is fetched, this primary key and version attributes are always fetched. It is not incorrect, however, is to specify primary key attributes or version attributes. Attributes are other than primary key and version attributes are assumed not to be fetched unless the attributes is specified. Following rules apply to the specification of attributes. If the attribute is an embeddable attribute, the attribute is specified in an attribute not, but a subgraph is not specified for the attribute, the default fetch graph for the embeddable is fetched. If a subgraph is specified for the attribute and attributes are embeddable, are fetched according to the specification in the corresponding subgraph. If the attribute is an element collection of the basic type, the attribute is specified in the attribute node. The element collection together with its basic elements is fetched. If the attribute is an element collection of embeddables, the attribute is specified in an attribute node, but the paragraph is not subgraph is not specified for the attribute. The element collection together with the default fetch graph is of its embeddable element is fetched. If the subgraph is specified for the attributes of the embeddable element are fetched according to the corresponding subgraph specification. If the attribute is 1-to-1 or many-to-one relationship, the attributes is specified in the attributes node, but the subgraph is not specified in the for the attributes, and the default fetch graph of the target entity is fetched. If the subgraph is specified for the attributes of the target entity is fetched according to the corresponding subgraph specification. If the attributes is one-to-many or many-to-many relationship, the attributes is specified in the attributes node, but subgraph is not specified. The collection is fetched and the default fetch graphs of the reference entities are fetched. If the subgraph is specified for the attributes, the entities are in the collection are fetched according to the corresponding subgraph specification. If the key of the map which has been specified in the attribute node is a basic type, it is fetched. If the key of the map which has been specified in an attribute node is an embeddable type, the default fetch graph is fetched for the embeddable. Otherwise, if the fetch of the map an entity and map key subgraph is not specified for the attributes node, the map key is fetched according to its default fetch graph. If the key subgraph is specified for the map key attribute, the map key attribute is fetched according to the map key subgraph specification. In this example, a number attributes would be eagerly fetched. Now we are considering named query annotation in annotations for queries. The named query and named queries annotations can be applied to an entity or mapped super class. The annotation type named query in package Jakarta persistent in module Jakarta persistent. It specifies static named query in the Jakarta persistence query language. Query names are scoped to the persistent unit. The named query annotation can be applied to any entity and to an entity or mapped superclass. Named query annotation is used to specify the named query in the Jakarta persistence query language. Name is the element used. Name element is used to refer to the query which when using the entity manager methods that create the query object. Query element must specify the query string in Jakarta persistent query language. Lock mode element specifies a lock mode for the result returned by the query. If the lock mode other than none is specified, the query must be executed within the transaction and persistent context joined to the transaction. Hints element may be used to specify query properties, and hints properties defined by this in the Jakarta specification must be observed by using provider. Hints defined by this specification should be observed by the provider when possible. When the specific hints that are not recognized by the provider must be ignored. Named query and named queries annotations can be applied to an entity or mapped superclass. Here now we are considering named query in other elements of the entity mappings element in XML overriding rules in XML object relational mapping descriptor. The named query defined by the named query sub-element applies to the persistent unit. The named query defined by the named query sub-element applies to the persistent unit. It is undefined if multiple mapping files for the persistent unit contain named query of the same name. The named query defined is added to the named queries defined in the annotations. if a named query of the same name is defined in the annotations, the named query defined by the subelement overrides that definition. Now we are considering named native query. The named native query defined by the named native query subelement applied to the persistent unit. It is undefined if the multiple mapping files for the persistent unit contain named queries of the same name. The named native query defined is added to the named native queries defined in annotations. If the named query of the same name defined in the annotations, the named query defined by the subelement overrides that definition. Now we are considering the name stored procedure query. The name stored procedure query defined by the name stored procedure query subelement applied to the persistent unit. It is undefined if the multiple mapping files for the persistent unit contain the named stored procedure queries of the same name. The named stored procedure query defined is added to the named stored procedures queries defined in the annotations. If the named stored in the procedure query of the same name defined in the annotations, the named stored procedure query defined by the subelement override that definition. Now we are considering named query in subelements and attributes. The named query defined by the named query defined by the named query subelement is added to the named queries defined in annotations and other named queries defined in XML. If the named query of the same name is defined in annotation, the name query defined by the subelement overrides the definition. If the name query subelement is present and attributes of subelement of the named query element are not explicitly specified, their default values are applied. The named query defined by the named query subelement applies to the persistent unit, and it is defined if multiple mapping files for the persistent unit contain the named queries of the same name. Name native query, then the named query defined by the named native query of subelement is added to any unnamed queries defined in annotations and other named queries defined in XML. If the named query of the same name is defined in annotations, the named query defined by the subelement override that definition. If the named native query subelement is present, the attributes of subelement of that named native query subelement are not explicitly specified, their default values are applied. The named native query defined by the named native query subelement applied to the persistent unit. It is undefined if the multiple mapping files for the persistent unit contain the named queries of the same name. The named stored procedure query. The named stored procedure query defined by the named stored procedure query subelement is added to any named stored procedure queries defined in annotations and other named stored procedure queries defined in XML. If the named stored procedure query of the same name is defined in the annotations, the named stored procedure query defined by the subelement override that definition. If the named stored procedure query subelement is present, the attribute of or subelement of that named stored procedure query subelement are not explicitly specified, their default values are applied. The named stored procedure query defined by the named stored procedure query subelement applied to the persistent unit. It is undefined if the multiple mapping for the persistent unit contain named stored procedure queries of the same name. Example, we can consider illegal state exception. If called for a Jakarta persistent query language update or delete statement in method list get result list in interface query.